It's Sorkin. Today we have a problem when we are given M to N 2D binary grid, which represents a map of land and the water. 1 is being a land and the 0 is being a water. And we need to return the number of islands. So the island also, we are given definition of Iceland. Iceland is surrounded by water and is formed by connecting adjacent lands horizontally and vertically. So for example, in this case, this is one island, right? Because it is formed by connecting the adjacent land horizontally and vertically. And also we may assume that all 4 edges of the grid are surrounded by water. So for example, in this case, all 4 edges, so these are also these are surrounded by water. So this is the first example, and the next example we have, this is the first island, right? This is the second one, and this is the third one. So that's why the response is 3. So in this case is 1. How we are going to solve this problem? We are going to use the DFS approach, DFS search approach, and we are going to, for each grid, we are going to check that if the value is equals to 1, then it means that, for example, let's take this example, right? If the value is equals to 1, it means that it's an island. So we are going to deep first search. So we are going to, and as we go, so we will maintain our result, right? Result. So we are going to visit every cell, and for example we are visiting this cell, it equals to 1, it means that our result is 1, so we have at least 1 island. So we are deep first searching, and as we deep first searching, we are replacing all these values, we are marking as a visited with the V, right? So we are in the first iteration, we are visiting these 2, then we are visiting this one, and we are marking it as a V visited. So then we are visiting so we are going to visit every cell, right? So first we visited this one, so first we visited this cell, right? And deep first searched here and here for this cell. Then we are going to the next cell, the value is not equals to 1, so we are not increasing our result, and we are going to visiting every cell here. So once we are at this position, it equals also to 1, right? So it means that we are increasing our result. We have 1 more island here, and we are deep first searching. We are deep first searching, and since there is no adjacent land, we will not visit. So we will not set any value, any adjacent land. So there is no adjacent land. So in this case, we are going further. So then we go to we visit this cell, every cell is not equals to 1. So we go to this position, right, to this cell, and this cell also equals to 1, right? So it equals to 1, it means that our result, we are increasing our result also to 1. And we are also deep first searching, and all adjacent land, since it's a part of this island, we are setting that to V, and the V as visited. Okay, first thing that we are going to do, let's define our result, which is equals to 0, and we are going to return our result, so number of islands, right? Now we can go and visit every cell. So for that, let's do I, which is our x-axis, and I is less than grid length, and our I plus. So the same we can do for the y-axis. Let's just copy paste that here, and we are doing the same for J and the J0, grid 0, so y-axis, and J++. So what we are checking here, we are checking that if our grid I and J, if that equals to 1, right? What we have an island, so we can deep first search, and all adjacent land we can mark as a visited, right? So that's exactly what we are doing here. So we are in our grid. So we are passing our grid here. We are passing our I and the J, right? X and Y coordinates. and also we are incrementing our result because we have an Iceland. Now let's implement our DFS method or function. So it's gonna be void, let's call it DFS, and it's gonna take what? It's gonna take our grid, right? Let's copy paste from here. It's gonna take our grid, it's gonna take our int x-axis, and it's gonna take int y-axis. Okay, so what we are doing here, first thing, let's just set our grid. If in our grid y, x and y, let's set them to visited, right? So we are setting that as a visited, we are setting that as a v, and now we can explore that in 4 directions. So we can call DFS method, and we are passing our grid. We are passing our x plus 1 in 4 direction, right? And y, right? And the same we can copy paste here 3 times. We are doing x plus 1, right? X minus 1, then we are doing here y plus 1 and the y minus 1. Okay, y minus 1. And also we need to set up here our base cases, our base case. What is our base case? Our base case is that the first, if we are going over our grid, we need to backtrack. So for that, x less than 0, or our x more than or equal to our grid length, and also or our y is less than 0, right? And the same we can do for y here. Y is if more than or equals to our grid 0 length, then what we are doing, we are returning, right? We are just backtracking. We are returning from here. And also one more case, if it is not equal to 1, which means that it equals to 0 or it's visited. So in that case, we are also backtracking. So to do that, we are for our grid x and y, if that is not equal to 1, then in that case also we are backtracking. Okay, that's it. Let's run it. Okay, it should be y here and not int but the character 1. Okay, let's run it one more time. Okay, great, it works as expected. Let's now calculate our time and space complexity. Our time complexity is, since we are visiting every cell in the grid, it's m to n, right? And how about our space complexity? Space complexity is determined by the recursive calls in our DFS function. So and in that case, the size of the stack is the minimum of our m or n. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.